In today's video, we're going to be discussing how we name cycloalkanes. In other words, alkanes that are in rings. So, what we're going to do is we're going to use the cyclo prefix, meaning that it's a ring, and then our substituents will be in alphabetical order, just like we did with linear straight chain alkanes. If we have more than one substituent, we want to number them so that the lowest numbers are used. And if you've only got one substituent, you don't need to put a number because it's assumed that that substituent is on carbon number 1. So here's an example. This is a 5-carbon chain, right? So it's a pentane. But because it's in a ring, we're going to call it cyclopentane. And this carbon has a methyl group on it, but none of my other carbons have any substituents. So the parent chain is cyclopentane. There's a methyl group. And so the name of this is just methyl cyclopentane. You don't need to put one methyl cyclopentane because since there's only one substituent, we're assuming that the substituent is on carbon number 1. Okay, so that's all I need to worry about if you've only got one substituent. Now, if you've got 2 substituents, we have to figure out how we should number. So let's look at this molecule. Carbon number 1, 2, 3, 4, 5, 6. This is a 6-carbon chain, so that's a cyclohexane. This is carbon number 1, and this is carbon number 3. How did I decide that this was carbon number 1? Well, the substituents need to go in alphabetical order. So E comes before M, right? So I want to pick this as carbon number 1. And we're going to number clockwise. Here are some of our other options. Let's make sure we understand why those options are not correct. We're not going to call it 1-methyl 3-propyl because number 1, that's not even a propyl group, that's an ethyl group. And number 2, again, E comes before M, so we would start numbering from here, not from here. And then if we did identify this as carbon number 1, we don't number clockwise because that would make it 1-ethyl 5-methyl. Right? And it shouldn't be 1,5, it should be 1,3. So my final correct answer is 1-ethyl 3-methyl cyclohexane. Here are 2 more examples. We could have begun numbering from the top or from the bottom. If we started numbering this way, we go 1, 2, 3. If we started numbering here, we go 1, 2, 3. So either one works. So this is 1, 2, 3 trimethyl cyclopentane. With the next one, we want to begin numbering here because B comes before C, and B and C both come before E. Right? So this is 1-bromo, 3-chloro, 5-ethyl cycloheptane because it's a 7-membered ring. Now, one of the things that you can have in cyclic molecules is you can have molecules where the substituents are sticking up or sticking back. So here's an example of the trans stereoisomer. This little dash means that this methyl group is coming out of the screen towards you. And this dash means that it's going behind this board. It's going behind the screen. So if one is going up and one is going back, we call that the trans isomer. And if they're both the same, so both of these are coming up, we would call it cis. Now you can only see cis-trans isomer if it's drawn in such a way that shows it. If I don't give you a drawing that has wedges and dashes, you won't have any way of knowing. So you can only do this if the molecule is drawn in such a way that you can see wedges or dashes. So here's an example. One of them is a dash, one of them is a wedge, so this one must be the trans isomer. This is a methyl group, right, because this is just a CH3 we're imagining here. And this is an ethyl group, right, because there's CH2, CH3. So the final answer here is trans. Carbon number 1 is right here because E comes before M. So trans, 1-ethyl 3-methyl cyclopentane. And that's the end of our discussion on cyclic nomenclature.